Hi, my dear students. Welcome to India's biggest online platform, Educational Institutions. Today, we are going to start a wonderful chapter, ray optics. In this session, we can talk about some introduction to geometrical optics. In this session, first we can have a look on the some fundamental definitions used in geometrical optics. After that, applications of laws of reflection. Finally, we can solve some problems related to laws of reflection. Let's start the session. Geometrical optics is the study of light in which dimensions of objects much higher than the wavelength of light. Here we are having different objects we will be discussing in upcoming classes. Here mirror, lenses and prism. Size of these objects much higher than the wavelength of light in this particular geometrical optics. In geometrical optics, the propagation of light is represented by a ray. The propagation of light, see here, the propagation of light is represented by a ray. The arrow represents direction of propagation. In this particular ray, you will be having an arrow. Arrow represents direction of propagation. Just see here, this is the ray. Here, this particular ray coming from the light and incidenting on the eye. Observer. Okay na? So here this is the ray. Arrow represents direction of propagation. Generally the propagation of light represented by a ray. Okay, so here one more thing I want to tell you, light is nothing but it's a part of electromagnetic spectrum which helps us to see the objects. In general, light is used to see the objects. Actually, light is the part of electromagnetic spectrum. One more thing I want to tell you, light always travels in a straight line. Path of light is called a ray. Bundle of rays is called a beam. Understood now? So these all are some fundamental definitions in this particular geometrical optics. Some fundamentals of geometrical optics. Here one important point here is dimensions of objects much higher than the wavelength of light. After that, the propagation of light is represented by a ray. Ray, in this particular ray, you will be having arrow. Arrow represents direction of propagation. And light is a part of electromagnetic spectrum which helps us to see the objects. Understood now? So it always travels in a straight line and path of light is called a ray. Bundle of lights is called a beam. Bundle of lights is called a beam. These all are some fundamental definitions of this, but some introduction to geometrical optics. Now we can have a look on the different objects. Obviously, in geometrical optics, the size of the objects are much higher than the wavelength of light. What are the different objects we need to study? Just see here, we are having two types of objects. One is luminous objects and non-luminous objects. What is meant by luminous objects? See here, the objects that emit light. The objects which emit light. See here, which emit light, or the objects which produce the light. Which produce the light by themselves are known as luminous objects. For example, we are having sun. Sun, it produces the light. Okay, so this particular bulb, it emits light. A bulb can't produce the light, it emits light. Bulb and then candle, these all are emitting light. Understood now? Light is a form of energy. It is emitted by the luminous objects, or else it can produce the light. Okay, so in both the case, we can call those objects as luminous objects. I repeat, luminous objects are the objects which emit light or produce the light themselves, are known as luminous objects. You can see the sun, bulb, and candle. So it emits the light. That is why you are calling sun, bulb, and the candle or luminous objects. For example, now we need to have a look on the non-luminous objects. Of course, non-luminous objects are the objects which can't emit the light. Okay, so it can't produce the light. See here, objects that don't produce their own light are known as non-luminous objects. For example, chair, bench, table, and wall. These three, or else whatever the object which is not producing, which is not emitting the light, those objects are called as non-luminous objects. So these are the two different objects we need to study in geometrical optics. So I repeat, here we are having two types of objects. One will be, here we are having two types of objects. One is luminous objects and non-luminous objects. In case of luminous objects, it emits light or produce the light. In case of non-luminous objects, which can't emit or produce the light themselves, whenever a light incident on non-luminous objects from the source is nothing but luminous objects. When light incident on the non-luminous object, you are able to see these non-luminous objects. Understood now? These objects can't produce or emit the light themselves. In this manner, we can classify the objects as two types, luminous and non-luminous objects. Now, a wonderful topic, reflection. It is one of the important topic in ray optics. Understood? Entire geometrical optics, reflection is one of the important topic. We need to discuss in detail about reflection. After that, properties of light, then laws of reflection. First, what is reflection? See here, if the light rays strikes the boundary of two media, then the part of light gets absorbed and part of light will be reflected into the same medium. Here, some amount of light incident on the body, in that some fraction of amount of light will be absorbed by the body. Some fraction of amount of light will be reflected from the body. Here, reflection, main important part of the reflection here is light will be incidenting from one medium. It is reflected to the same medium. Here, medium will be same in case of reflection. In case of refraction, medium will be different. So we can discuss one by one in detail. This is the source of light and observer and object. From the source, light will be incidenting. This is the incidenting. Here, I can say that this is the incident ray. This would be incident ray. Light is incident ray. Some amount of light is incidenting on the object. After that, it is reflected ray. I can say that this would be reflected ray. Here, some amount of light incidenting on the object from the source. I think this is medium 1. I can say that this would be medium 1. It is reflected to the same medium. Medium is same here. Okay. In case of reflection, medium will be same. Reflected to the same medium. Here one thing I want to tell you, source, this is the source. From the source, incident ray is coming and incidenting on the object. Here some amount of light will be reflected and it is reaching the observer. That is why you are able to see these objects. Here the chair is what? Non-luminous object. This chair is not emitting the light or not producing the light. But how are you able to see this object? Because of this particular process. From the source, light is incidenting on the non-luminous object, then it is reflected from the surface of non-luminous object and it is reaching the observer. Okay, see here, since the non-luminous objects like chair, wall don't produce their own light, these objects can be seen if the light from the luminous objects falls on them, reflects to the eye and creates the perception of vision. You are able to see these non-luminous objects because of this particular reflection of light. This reflected ray reaching your eye, then retina, this particular retina present inside the eye will feel the vision, perception of vision. You can see that objects. This particular process will take place in fraction of seconds. That is why you are able to see the objects, mainly because of this particular process. Understood now? From the source, light is coming. This is the incident ray, incidenting on the chair, reflected from the surface, reflected to the same medium. Same medium is very, very important. Reflection is the phenomena. In this medium will be same. Now we can discuss in detail about reflection. In some more discussion about reflection here. Very simple. This is the source. So main source of seeing objects is sun. From the sun, light is coming and incidenting on the object, and the reflection, reflected ray reaching your eye. By that you are able to see the objects. Here this is the object. From the source is a sun. From the source, incident ray is coming, incidenting on the object and reflected from the object, and the reflected ray reaching the observer eye. Okay, so in this manner, this is the incident ray. I can say that this would be incident ray. This would be incident ray, reflected ray. This would be reflected ray. So you are able to see that, you are able to feel that object, you are able to see that object, you will get perception of vision. See this, we can see any objects, it may be luminous object or non-luminous object, because of the following reasons. One will be the main reason is reflection. Due to reflection of the light, and if the radiation from the luminous heated object lies in the visible region, whatever the radiations commit, every body emits radiation. If those radiation within the visible region, you are able to see the objects. That part we can discuss in the chapter radiation. Okay, so for time being, we need to talk about reflection. Okay, so because of the reflection, incident ray incidenting on the object, reflected ray reaching the observer, by that you are able to see the objects. This is the, here medium will be same. Okay, so here reflected ray and incident ray coming from the source. This is the medium one, and the reflected ray is reflected. This particular reflected ray is coming into the medium, same medium. Here medium will be same. We can discuss properties of the light. So this is also one of the important topic here, properties of the light. When the light ray, here we need to discuss about reflection and refraction. What is the reflection and refraction? So we can discuss clear-cut difference between reflection and refraction. See here, when the light ray falls on the interface of two mediums, there will be two possibilities. We already discussed this part. When light ray incidenting on the surface, there are two possibilities. Some amount of incident ray is reflected from the surface, some amount of incident ray absorbed by the surface. Once the incident ray, some amount of light will be reflected to the same medium. Some amount of light will be absorbed. That absorption process, that is nothing but refraction. Here, in case of refraction, mediums will be different. In case of reflection, that is reflected ray is reflected into the, that is passes into the same medium. Medium will be same in case of reflection. Medium is not same in case of refraction. See here, the ray reflects back to the same medium. The ray transmit into the other medium. We can discuss in detail about this reflection and refraction. This is the source of light, and this is the interface of two mediums. This is the interface of two mediums. Here medium 1 and medium 2. Here medium 1 and medium 2. Just observe. Medium 1, medium 2. Light ray incidenting, this is the source. Okay, here light ray is coming from the source, incidenting on the surface. Here some amount of light will be reflected from the surface. Some amount of light is transmitted into the other medium. Okay na? So here this particular, here the ray, this particular incident ray, reflected ray is back to the same medium. Okay na? Incident ray and reflected ray both are in the same medium. Understood na? But this refracted ray is transmitted into the other medium. Incident ray coming from the medium 1 and reflected ray is back to the same medium. Refracted ray is transmits into the other medium. In case of refracted ray, medium will be different. Understood na? So it is transmits into the other medium. Understood? So here other medium, that is one of the important topic. Because of that, velocity of the light and wavelength of the refracted light will be different. Understood na? Here velocity of incident ray, velocity of reflected ray, both will be same. Frequency is same for all the rays, but wavelength case, wavelength here, wavelength of incident ray, wavelength of reflected ray, both will be same because of same medium. Coming to refraction, velocity of the refracted light and wavelength of the refracted light is not same as the wavelength and velocity of the incident ray. Understood na? So here V dash and lambda dash, here V and lambda. So you can observe here, in case of reflected ray, velocity is not changing, wavelength is not changing, and frequency, velocity, frequency and wavelength of the reflected ray is not changing. It is same as the incident ray. But in case of refracted ray, velocity of refracted ray and wavelength of the refracted ray, both are changing. Both are not same as the velocity and wavelength of the incident ray. You can clearly see this here. Now we can discuss about in detail about this. What is meant by, we already seen this here. Incident ray coming from the source, medium 1 and medium 2. Incident ray coming from the source, incidenting on the surface and reflected back to the same medium, transmits into the other medium. Incident ray, reflected ray, refracted ray, and wavelength, frequency and velocity, frequency and wavelength, velocity, frequency and wavelength, and both are same in this case. Here velocity and wavelength both are changing. So coming to the reflection clear-cut definition here, the phenomena in which the incident ray reflects back to the same medium of the origin of light is known as reflection. The ray is known as reflected ray. Here the phenomena in which incident ray reflects back to the same medium of origin of the light. Origin of the light is nothing but, what is the origin? So it is coming from the source. Of course, this is the origin. Origin of the light present in the medium 1. It reflects back to the same medium. Understood now? So that is the basic phenomena of this particular light is nothing but reflection. Reflection is the phenomenon in which incident ray reflects back to the same medium of origin of light is known as reflection. The ray is known as reflected ray. And here this is the incident ray and the reflected ray. Here I can say that incident ray, this would be incident ray, this would be reflected ray, Okay, so here in case of, we already discussed this part, in case of reflection, velocity, frequency and wavelength of the light remains same as the incident ray. Okay, now, so here whatever the wavelength and velocity, frequency, wavelength of incident ray, velocity, frequency and wavelength of reflected ray exactly same. Understood now? So these are not changing in case of reflection. Understood? So now we can talk about refraction. What is meant by refraction? The phenomena in which the incident ray transmits through the interface of two mediums and travels into the other medium is known as refraction, and the ray is known as refracted ray. We already discussed this part. Here the ray transmit into the other medium. We already discussed this, medium 1 and medium 2. Some amount of light is incidenting on the surface, some amount of light will be reflected from the surface, some amount of light will be refracted, transmitted into the other medium. That phenomena is nothing but refraction. Here incident ray, reflected ray and refracted ray, wavelength, frequency and velocity here. So we already discussed this part. Here this part is what? This is the medium 1 and it is transmits into the other medium. Here this is nothing but incident ray, the origin of the light, incident ray, the origin of the light present in the medium 1, but it transmits into the other medium. That phenomena is nothing but refraction. This is refracted ray. This would be refracted ray. We already discussed this. Refraction is the phenomena in which change in velocity of the light occurs due to change in medium. Hence, only frequency of the light remains same after refraction. Frequency is not changing in case of reflection and refraction. In case of refraction, velocity of the light is changing and wavelength of the refracted ray is changing. Understood now? So here this is the velocity, here V dash. Velocity of the refracted ray is not same as the velocity of incident ray. Wavelength of refracted ray is not same as the wavelength of incident ray. This is all about some funda related to refraction. Understood now? So this is the some funda related. Main thing is medium. Understood? I repeat here. I repeat this. The phenomena in which incident ray transmit through the this incident ray transmit through the interface of two mediums, transmits into the other medium, travels into the other medium. Understood now? Here transmit through the, this is the interface, transmit through the interface of the two mediums. Understood now? So that is the refraction. Incident ray coming from the medium 1 and refracted ray transmits or travels into the other medium. That is the basic difference between reflection and refraction. This is the some funda related to reflection and refraction. Now, terminology used in reflection. See here, this is the angle of incidence, angle of reflection, both are important. These two are one of the popularly used terms in this particular reflection chapter. Understood? So here angle of incidence, this is the mirror, this is incident ray here, and reflected back to the same medium, this is reflected ray, incident ray, reflected ray. Now we need to draw the normal to the plane surface, mirror or plane surface, that is fine. This plane surface or polished surface, okay na, both are fine. Here we need to draw normal to the surface, plane surface. What is the normal to the plane surface? We need to draw the perpendicular or normal to that. Now, angle made by the incident ray with normal is nothing but angle of incidence. Now, angle of reflection is nothing but angle made by the reflected ray with the normal is nothing but angle of reflection. Understood now? The angle that the incident ray makes with the normal is known as angle of incidence, and it is denoted with I. The angle made by the reflected ray with the normal is nothing but angle of reflection. It is denoted with R. Understood now? Angle of incidence, angle of reflection. Okay, so both are very, very important. So I repeat this. This would be plane surface. Here, I repeat this. This is the plane surface. Incident ray incidenting on the plane surface, reflected back to the same medium. This is reflected ray, incident ray, reflected ray. Now we need to draw normal to the plane surface. This is the normal to the plane surface. Angle made by the incident ray with normal, angle of incidence. Angle made by the reflected ray with normal is nothing but angle of reflection. These two definitions are very, very important. Angle of incidence I, angle of reflection R. Now we can have a look on the one of the important topic, laws of reflection. Here we already know this part. Just observe angle of incidence, angle of reflection. Here I and R. What is laws of reflection? So angle of incidence is equal to angle of reflection. is called law of reflection. So the angle of incidence I equal to angle of reflection R. I equal to R. Here I equal to, I can say that I equal to R. Angle I equal to angle R is nothing but laws of reflection. Law of reflection. Angle I equal to angle R. Now, incident ray, reflected ray and normal at point of incidence all are present in the same plane. Understood now? So here incident ray, this is incident ray, reflected ray and normal at point of incidence all are lie in the same plane. This is one of the law of reflection. Laws of reflection are valid for reflecting surfaces of any shape. So these three are laws of reflection. Understood now? One of important law here is angle of incidence equal to angle of reflection, and these three rays present on the same plane, and this particular laws valid for any reflecting shape, any shape. Okay na, reflecting surface of any shape. Understood na? This is all about some introduction to this reflection, some fundamentals of reflection. Understood na? So laws of reflection is very important, and incident ray, reflected ray and angle of incidence equal to angle of reflection. Now we need to have a look on the some problems based on laws of reflection. Read the question carefully. See here, a ray of light is incident on a circle x square plus y square equal to r square, polished from inside as shown in the figure below. The coordinates x and y of the point at which the incident ray should fall such that the reflected ray becomes vertical after the reflection. Here the incident ray is horizontal, is given in the figure, and reflected ray is vertical. An incident ray is incident on the circle x square plus y square equal to r square. Here, see this would be incident ray. Here I can say that incident ray is horizontal. Incident ray is horizontal. Reflected ray is vertical. Reflected ray is vertical. So in order to get vertical reflected ray, the horizontal incident ray must fall at a particular point A. They are asking the coordinates of the point A. The coordinates of the point A, here x comma y. Coordinates of the point A equal to dash. They are asking coordinate of the point A. Here incident ray is horizontal and reflected ray is vertical. It's very simple to solve the problem. See here, the coordinates of point A, x comma y. What is given in the question? Circle x square plus y square equal to r square. Incident ray, incident at a point A. This is the incident ray. Incident ray is horizontal is given, and reflected ray is vertical. Reflected ray is vertical. Now we need to draw the normal to this particular point, this particular surface. Understood now? So if you draw the normal at any point on the circle, normal will be passing through the center of the circle. Normal must passes through the center of the circle. This is the normal passes through the center of the circle. Understood now? Now, the angle made by the incident ray with normal is called incident angle. Angle made by the reflected ray with normal is nothing but angle of reflection, angle of incidence, and angle of reflection. We already know this part. Just see here. We already know that angle of incidence equal to angle of reflection. So here I can write that part, angle of incidence. Angle of incidence equal to angle of reflection. From here, incident ray is horizontal, reflected ray is vertical. That is why I can say that angle of incidence plus angle of reflection equal to 90 degrees. Here it is 90 degrees. Here, angle of incidence equal to angle of reflection. That is why you can write it as 2I or else 2R equal to 90 degrees. 90 degrees. So I can confidently say that angle of incidence equal to angle of reflection equal to 45 degrees. 45 degrees. This angle of incidence, this is equal to 45 degrees. Angle of reflection, this is also 45 degrees. If it is 45 degrees, this is also 45 degrees. Understood now? 45 degrees, this would be 45 degrees. This is also 45 degrees. Understood now? So I can say that this is 45 degrees. This would be 45 degrees. Clear now? So in this manner, I plus R equal to 90 degrees, I equal to R. That is why I equal to R equal to 45 degrees. It is very simple to calculate angle of loss of reflection. Law of reflection, I equal to R. We already know that part. How to calculate the coordinates of the point A, X comma Y? It is very simple. Now we can draw normal to it. It is X and Y. Understood? So here, so I can say this may be M, perpendicular is drawn from triangle. Just observe. You can directly write X comma Y as minus R cos 45 comma R cos 45, or else from triangle, OMA, from triangle OMA, you want X. For that, you need to apply cos 45. What is cos 45? What is cos 45? Equals to X by R. X by R. Understood now? So, but it is what? It is a left side now. So that is why X equal to minus R. Here X equal to what? Here I can say that X equal to what? R cos 45. This would be R cos 45 degrees. So here X I can write. It is along the negative X direction. Negative X direction. That is why minus R by, this would be minus R by root 2. Here, what is sin 45? Here I can say that sin 45 equals to Y by R. Y by R. Here I can say negative minus R. Here Y equals to R sin 45. R sin 45 degrees. Here it is how much? R by root 2. Here X equals to minus R by root 2, because it is along the negative x-axis. It is along the negative x-axis. So this would be x equal to minus, here y equal to plus r by root 2, plus r by root 2. So you can directly write a, you can, if you are interested, you can directly write a x comma y equals to, here you can directly write, this would be, you can directly write a minus r cos 45 minus r cos 45 comma r sin 45 y minus, here it is along negative, it is in second quadrant, so x along negative x axis, this is positive y axis, that is why finally you can write a minus r by root 2 comma plus r by root 2. So here, if the incident at a point A, at a point minus r by root 2 comma plus r by root 2, if the incident at this point, after the incidence, the reflected ray will be vertical. So at this particular point, incident ray is incidenting, then only the reflected ray will be vertical. That is the question asked in this particular thing. Okay, na? So here we applied laws of reflection. It is very simple to solve the problem. Basic level geometry. Understood na? What is the answer to this question? Minus r by root 2 comma r by root 2. So what is the answer to this question? What is the answer to this question? A x comma y equals to a minus r by root 2 comma r by root 2. This is the thing. Minus r by root 2 comma plus r by root 2. Okay, so basic level geometry we applied. It is very simple to solve the problem. Now we can have a look on the next problem. See here, read the question carefully. A ray of light incident on circle x square plus y square equal to r square, polished from inside as shown in the figure below. The coordinates x and y of the point at which the incident ray should fall, such that the reflected ray becomes vertical after the reflection. Similar to the last problem, it is very simple question. So here the point of incidence is in third quadrant. Understood na? At this particular point P. Here incident ray is horizontal, reflected ray, this would be, reflected ray is vertical, reflected ray is vertical, incident ray is horizontal. Understood? Here incident ray is horizontal, reflected ray is vertical, but angle, this is point of reflection, the point of incidence is in third quadrant. Understood na? That point at any point on the circle, so depending on the condition, you are in position to calculate the point B or A, whatever it may be. So they will be giving some data related to this particular to give angle of incidence and angle of reflection. By that you can easily calculate the coordinates of the point. Try to solve this problem. See here, they are asking the coordinates of the point B. Circle x square plus y square equal to r square. Here the point of incidence, this is the P is the incident ray, and horizontal, here the incident ray is horizontal, and B is the, at this particular point, incident ray is incidenting on the circle. After the reflection, the reflected ray is vertical. Similar to the last problem, now we need to draw the normal at this particular point, normal passing through the center of the circle, Now we already know the definition of angle of incidence. This is the radius, angle of incidence, angle of reflection. Angle made by the incident ray with normal, angle of incidence, angle made by the reflected ray with normal, angle of reflection. So here in this laws of reflection we already know. Now similar to the last problem, from here what you are observing, tell me, from here what you are observing? Incident ray is horizontal, reflected ray is vertical. That means you can say confidently I plus R equals to 90 degrees. I equal to R. This is the law of reflection. So from here, you can say, if you substitute that part, 2I equals to 2R equals to 90 degrees. I equal to R equal to 45 degrees. I can say that this is angle of incidence. Angle of incidence is nothing but, how much is this? 45 degrees. Angle of reflection, how much is this? 45 degrees. Angle of reflection 45 degrees. That means this would be 45, this would be 45, this is also 45 degrees, this is also 45 degrees. Understood now? So now tell me 45 degrees and 45 degrees. Now we need to calculate the coordinates of the point B. For that we need to draw the normal. So it is X and Y. Here X and Y both are negative. Understood now? So in this case, I can say that this is how much? Negative. This is negative. This is also negative. X and Y both are negative. Here I can say it would be normal. You can take from triangle, X and Y both are negative. Here from triangle, from triangle OMB, now tell me how much you getting? To get X, cos 45 how much? This same way you will be calculating. Cos 45 degrees equals to X by R. X equals to R cos 45. X equals to R by root 2. Here X is negative. I can say that X is what? Negative. So that is why finally we can write X equal to how much? Because X, the distance along the negative X direction. So minus R by, this would be minus R by root 2. Now, if you are interested to write, it is very simple. Straight away also you can write. That is up to you. Sin 45, if you get some experience, you can easily write. Sin 45 equals to how much? What is sin 45? Y by R. Y equal to R sin 45. Degrees. Here this part, what is Y? Y also negative. Here Y also negative. So here Y equals to minus R by root 2. So here, if you are interested to write this B directly, in what manner you will write? Tell me. B B x comma y equals to B. You can write this is r cos 45, r sin 45. Both are negative. Minus r cos 45 minus r cos 45 minus r sin 45 degrees. So equal to B. This is B minus r by root 2 minus r by root 2 comma minus r by root 2 minus r by root 2 comma minus r by root 2. So what is the final answer to this question? What is the final answer to this question? B x comma y equals to B x comma y equals to B minus r by root 2 comma minus r by root 2. Okay, so in this manner we'll be calculating the coordinates of point B. If the incident ray incident at this particular point B equal to minus r by root 2 comma minus r by root 2, then the reflected ray will be vertical. The reflected ray vertical and it is reflected downward direction. So it is very basic level geometry. So what is the final answer to this question? Minus r by root 2 comma minus r by root 2. So here, what is the final answer to this question? Here B x comma y equals to minus r by root 2 comma minus r by root 2. So it is very simple to solve the problem. So we applied law of reflection and basic level geometry. This is the way to solve this problem. Now we can have a look on the next problem. Read the question carefully. A ray of light incident on circle x square plus y square equal to r square polished from inside as shown in the figure below. The coordinates x and y of the point at which the incident ray should fall such that reflected ray deviates by 120 degrees after the reflection. What is the angle of deviation? So we need to measure with this. This would be 120 degrees. After the reflection, this is the reflected ray. This is the reflected ray. Here, this would be this is the reflected ray. I can say incident ray and reflected ray. This is reflected ray. It is little interesting. Reflected ray. This is incident ray. Incident ray. Incident ray. Here what is happening? Incident ray, incident at point C. After the reflection, reflected ray deviates 120 degrees. Deviates 120 degrees. Scale. This would be 120 degrees. 120 degrees. Deviates 120 degrees. Now we can try to solve this problem. See here. So this is the circle. X square plus y square equal to r square. Here incident ray is horizontal here. Incident ray, incident at point C, x comma y. After the reflection, this is the reflected ray. After the reflection, it is deviated by 120 degrees. Now we need to draw the normal at point C. Normal passing through the center of the circle. So normal passing through the center of the circle. This is the normal. Angle made by the incident ray with normal is called angle of incidence. Angle made by the reflected ray with normal, angle of reflection. So now law of reflection, this is the, now we need to calculate this particular I. Very simple. We already know that I equal to R. Here total will be I plus R plus 120 degrees equal to how much? 180 degrees. I plus R plus 120 degrees equal to 180 degrees. From here I can write I plus R equals to how much? 60 degrees. This would be 60 degrees. We already know a law of reflection. I equal to R. From that we can write I equal to R means what? Here 2I equal to 2R equal to 60 degrees. If I equal to R, then I and R will be 30 degrees. Very simple. I equal to R equal to 30 degrees. So that is why if I equal to, what is this angle? Tell me, what is this angle? 30 degrees. What is R here? This would be 30 degrees. If it is 30 degrees, then it would be 30 degrees. This is also 30 degrees. If it is 30, it would be 60 degrees. Now, very simple. Here it is how much? 30 degrees. Now it is a R. Now we can draw normal to this. X and Y. Here I can say it would be normal. Maybe it is M. So now we need to take from triangle OMC. From triangle, you already experienced in these calculations. From triangle OM, this is the from triangle OMC. From triangle OMC, to calculate X. X is what here? X will be, here it is negative. X will be negative. Y will be, Y is what? Positive. Y is positive. X is negative because it is towards negative X direction. Y, it is along positive Y direction. So now tell me, what is cos 30? How much? Here I can say that cos 30 degrees equals to X by R. Sin 30 equal to how much? Y by R. So here, what is this? What is X? X equals to, what is X? Here X equals to R cos 30. Y equals to R sin 30 degrees. Here X is what? Of course, negative. This is negative. X is negative. So finally, what is X? Here X equals to minus R cos 30. Y equal to R sin 30. Or straight away also will get R cos 30 horizontal component, R sin 30 vertical component, position vector. R cos 30 negative, R sin 30 positive. Okay, so Cos 30 is nothing but how much? Minus root 3 r by 2. X equal to y equal to r by 2. So finally, what is the point C here? What is the point C here? So here the point C, I can write it as minus root 3 r by 2 comma r by 2. This is the point. Minus root 3 r by 2. This is the point C. So x will be negative, y will be positive. If you are interested, you can directly write this point C. You can directly write this point C. C x comma y. C x comma y. This would be equal to what? C. So r, negative direction, cos 30, horizontal component, minus r cos 30. Minus r cos 30 degrees plus r sin 30 degrees plus r sin 30 degrees. Here C minus root 3 r by 2. R by 2. So straight away also we can answer it. But so if you are lagging fundamentals, I think so you can calculate one by one. Take triangle and nothing wrong in that. Straight away also we can answer. Once you become expert in the subject, you can directly write x equal to minus root 3 r by 2, y equal to r by 2. Yeah, very simple problem. What is the final answer to this question? Minus root 3 r by 2 comma r by 2. What is the final answer to this question? Answer to this question. Here C x comma y. This would be C minus root 3 r by 2 comma r by 2. If incident at this particular point, okay na, then the reflected ray will be deviated by 120 degrees. Then it will become reflected ray. This is the reflected ray. This is the reflected ray. This would be incident ray. Incident ray. Yeah, this is very simple problem. So yeah, so last time reflected ray is vertical, but here reflected ray deviated by 120 degrees. Whatever the question it is, based on circle and incident ray, you are in position to answer. So even though incident ray is like this, here incidenting at any point on the circle, incident ray is incidenting on the circle. So based on the condition, in what manner the reflected ray is, based on that you can easily solve the problem. Understood now? Yeah. Now we can have a look on the another problem. Read the question carefully. A ray of light is incident on a parabola. Last time what we discussed, ray of light is incident on a circle, but here a ray of light is incident on parabola. X equal to y square, polished from inside as shown in the figure below. The coordinates x and y of the point at which the incident ray should fall such that the reflected ray becomes vertical after reflection. So after reflection, this would be reflected ray. I can say that this is what? Reflected ray. This is reflected ray. This is incident ray. Here incident ray is horizontal. Incident ray. In this question, they have given incident ray is horizontal, reflected ray is vertical. Here incident ray, incident on parabola at a point P, I can say. At a point P, it is incident on parabola. Now we need to calculate the coordinates of the point P, x comma y. These are the options given in the question. Understood na? Here it is what? Here the coordinates of the point P. The coordinates of the point P. X comma y equal to dash. They are asking. It's a parabola. Now, very simple. Coordinates of the point P, x comma y. It's a parabola. Parabola, equation of parabola is given. X and y here. P is the point. Equation of parabola. X equal to y square is the equation of parabola, or else y square equal to x. O, incident ray. This is the incident ray. Incident ray is horizontal. After the reflection, reflected ray is vertical. This is the reflected ray. Now we need to draw the normal at point P. This is the normal at point P. Now angle of incidence and angle of reflection. So we already know this angle of incidence equal to angle of reflection. So here this part we know that here I plus R equal to 90 degrees because incident ray is horizontal, reflected ray is vertical. I plus R equal to I plus R equals to 90 degrees. So from law of reflection, I equals to R. I equals to R. From here, you can easily write I equal to both are. I plus R equal to 90 means I equal to R in the sense I and R both are 45 degrees. Okay na? So 2I equal to 2R equal to 90 degrees. Then I equal to R equal to 45 degrees. I and R both are 45 degrees. This is how much? 45 degrees. This is also 45 degrees. 45 degrees. Now I am interested to draw tangent at a point P. I am interested to draw tangent at a point P. Tangent in the sense slope of the tangent is nothing but dy by dx. What is the slope of the tangent? Tangent drawn at a point P. Tangent drawn at a point P. What is the slope of the tangent? Slope of the what is the slope of the tangent? What is the slope of the tangent? So we already know that what is the slope of the tangent? M is the slope of the tangent. We know what is the slope? dy by dx is the slope of the tangent. We can write if it makes an angle theta here, if it makes an angle theta, what is the slope of the tangent? Equal to tan theta, can I say? Tan theta, can I say? What is the slope of the tangent? M equal to dy by dx. We already know that. We know that part from childhood. M equal to dy by dx. So a line makes an angle theta with the positive x-axis. Then what is the slope of that line? Tan theta. So now we already know normal makes an angle 90 degrees with the tangent. 90 degrees with the tangent. Understood na? Normal makes an angle 90 degrees with the tangent. So here, so total 90, if it is 45, from here to here how much? 45 degrees. From here to here, 45 degrees. Now, so if it is 45 degrees, this is also 45 degrees. This is also 45 degrees because it makes an angle 90. Okay, normal and tangent both are perpendicular because it is normal. Okay, normal and tangent both are perpendicular. That means it is 45, it should be 45. Then theta must be equivalent to how much here? 45 degrees. 45 degrees. Correct or not? Okay, so if it is 45, normal makes an angle 90 degrees, total 90 in the sense 45 45 total 90. If these two are parallel, if it is 45, it should be 45. So what is the slope of the tangent? What is the slope of this line? I can write tan 45 degrees. So here we know that how to calculate dy by dx. How to calculate dy by dx? Y square equal to x. Here I can write y square equal to x. So we can apply differentiation on both sides. Then what we will get? 2y differentiation on both sides, dy by dx equal to 1. So dy by dx equal to how much? Dy by dx equal to how much? 1 by 2y. 1 by 2y. Dy by dx equal to how much? Dy by dx equal to how much? 1 by 2y. 1 by 2y. So 1 by 2y is how much? 1 by 2y. Tan 45 equal to 1. Then y equal to how much? 1 by 2. 1 by 2. Y equal to 1 by 2. Understood na? So here I got y equal to 1 by 2. So we can substitute y equal to 1 by 2 in the sense, if you get y equal to 1 by 2, y equal to 1 by 2, then x equal to how much? You need to substitute that point here. Y square equal to x. Y square equal to x. We need to calculate for x. For x. How to calculate x? You need to substitute y equal to 1 by 2 here. You need to substitute y equal to 1 by 2. So here 1 by 2 whole square equal to x. Then x equal to 1 by 4. So we got x equal to 1 by 4. Understood na? Dy by dx, this is for the slope. This is for slope. What is the slope? Dy by dx. So in order to calculate the slope, we need to differentiate. Differentiation on both sides. What is the final point P? Tell me. What is the finally what is the point P here? What is the point P here? X comma y equals to P 1 by 4 comma 1 by 2. 1 by 4 comma 1 by 2. This is the final answer to this question. Final answer to this question. So what we did, tell me? What we did, tell me? Here we already done 45, 45. So this would be 45. Both are 45. Okay. It's very simple to solve the problem. Clear? Understood? Y equal to 1 by 2. So m equal to dy by dx. Once you differentiate y square equal to x, you differentiated. Finally, dy by dx equal to 1 by 2y. Okay, from here, what is the slope of this line? Tan theta. So this is the theta. This would be theta. This would be theta. Theta equal to 45 degrees. Okay. So if they give some other numericals, I think the numerical data, you are in position to answer by using this procedure. So here incident ray incidenting on parabola at a point P. So the reflected ray will be vertical. Even though the reflected ray deviated by some angle, you are in position to calculate. Here only thing is you need to apply law of reflection, I equal to R. So in what manner we need to draw the normal? Those things you should be very clear. Here we already know normal and tangent both are orthogonal. Okay na? Slope of the tangent into slope of the normal equal to -1. Here tangent and normal both are orthogonal at a point P. That is why this total 90 degrees, 45, then it would be 45. Theta you got, tan theta is the definition of the slope. dy by dx is also slope. From equation of the parabola, you calculated dy by dx equal to 1 by 2y. And we equated with tan theta, theta you calculated from the geometry. Finally, you got y equal to 1 by 2. You substituted y equal to 1 by 2 in the equation of parabola. Then you got x equal to 1 by 4. Finally, the point P, x comma y equals to 1 by 4 comma 1 by 2. That is the final answer to this question. 1 by 4 comma 1 by 2. Here, what is the answer to this question? What is the answer to this question? P x comma y equals to P 1 by 4 comma 1 by 2. Okay, this is the answer to this question. Understood? This is all about some fundamentals related to reflection. In this session, we discussed some fundamental definitions of geometrical optics and we applied laws of reflection and we solved some problems related to laws of reflection. Next class, we will be focusing on reflection in a plane mirror. Please do subscribe METube Intel Physics. Please attend all the sessions which we are conducting in METube Intel Physics YouTube channel. Please download the app from Play Store. Thank you. We can meet in the next class. Thank you.